Hello, in this lecture we will find the area of the green triangle. In the drawing we have triangle ABC, that is an equilateral triangle, and inside the triangle ABC we have the green triangle, and we want to find out the area of the green triangle. We also know that the size of BD is 2 units and the size of DC is 4 units, and AF equals to BF. Okay, first of all, in every equilateral triangle, all the angles of an equilateral triangle equals to 60 degrees. So angle BAC equals to 60 degrees, and also angle ABC equals to 60 degrees, and also angle ACB equals to 60 degrees. And all the sides of an equilateral triangle are equal to each other. That is to say, AB equals to AC equals to BC. Okay, so I'll write it down. AB equals to AC, that equals to BC. Because triangle ABC is an equilateral triangle, and all the sides of an equilateral triangle are equal to each other. That is to say, side AB equals to side AC equals to side BC. But we know that BD equals to 2 units and DC equals to 4 units. And BC equals to BD plus DC. So actually BC equals to 2 plus 4. So actually BC equals to 6 units. So AB also equals to 6 units. And we know that AF equals to BF. So we will define AF as X, that is to say AF equals to X, and if AF equals to X, then AF equals to BF, so BF also equals to X, and we know that AF plus BF equals to AB, and AB equals to 6 units, so actually AB equals to AF, that is X, plus BF, that is X. So AB actually equals to 2x. Okay, AB equals to 2x. So 2x, from this equality we can derive that 2x equals to 6 units. We'll divide this equality by 3 and we will get that x equals to 3 units. So x equals to 3 units. That means that the value of BEF is 3 units, and the value of AF is also 3 units. So in the next step we will define FD as A. FD equals to A, and DE will be defined as B, that is to say DE equals to B. In in the next step we will find the value of FD that equals to A according to the law of cosines. So actually, what is the law of cosines? Actually, the law of cosines states that in any triangle, if we have triangle if this side of the red triangle equals to A, this side equals to B, and this side of the red triangle equals to C, and the angle between side A and side B is theta, then according to the law of cosines, C squared equals to A squared plus B squared minus 2 times AB cosinus theta. Okay, so in any triangle we have the following relationship between the sides of the triangle and the angle between side A and side B. C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Okay? C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Okay, so we actually can implement the law of cosines in triangle, the small triangle BFD. So in the small triangle BFD, FD square, according to the law of cosines, FD square equals to BF square plus BD square minus 2 times BF times BD times cosinus 60 degrees. Okay, so in triangle BFD, FD square equals to BF square plus BD square minus 2 times BF times BD times cosinus 60 degrees. Okay, in triangle FBD, the small triangle, FD square equals to BF square plus BD square minus 2 times BF times BD times cosinus 60 degrees. Okay, but what is the value of FD. The value of FD is A according to our definition. So FD square is A square, that equals to BF square. BF equals to 3, so BF square is 3 square. 3 square is 9 plus BD square. BD equals to 2, so BD square is 2 square. 2 square is 4 minus 2 times BF is 3 and BD is 2, so it is minus 2 times 3 times 2 times cosinus 60 degrees. Cosinus 60 degrees is 1 over 2. In total, we got that A square equals to 9 plus 4 minus 2 times 3, 2 times 3 times 2 over 2. 2 over 2 is 1, so 2 is cancelled. Okay, so in total we got that A square equals to 9 plus 4, this is 13, minus 2 times 3, that is 6, or A square equals to 9 plus 4 is 13, minus 2 times 3 is 6. So in total we got that A square equals to 13 minus 6. Okay, 13 minus 6 is 7. So we got that A square equals to 7. Okay, A square equals to 7, so we will take a root out of this equality, and we will get that A equals to the root of 7 units. A equals to the root of 7 units. So we can write here that A equals to root 7, or root 7 units. Okay. In the next step, we will define angle BFD as theta, angle BDF will be defined as alpha, angle EDC will be defined as gamma, and angle DEC will be defined as beta. And we will calculate the value of sinus theta according to the law of sines. What is the law of sines? Okay, I will define the law of sines. What is the law of sines? Actually, if we have in any triangle, the law of sines can be implemented in any triangle. If we have triangle if this side of the rectangle is A, this side is B, and this side is C, This angle between B and C is alpha. This angle between A and C is beta. And this angle between A and B is gamma. According to the law of sines, the following relationship exists between the sides of the right triangle to the angles of the right triangle. A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, this equality is true for any triangle. Again, in any triangle, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, this rule is called the law of sines, and it is true for any triangle. Okay, so we actually can implement the law of sines in the small triangle BFD. In the small triangle BFD, BD over sinus theta, according to the law of sines, BD over sinus theta will be equal to FD over sinus 60 degrees. FD over sinus 60 degrees. Okay, so according to the law of sines, in triangle BFD, BD over sinus theta equals to FD over sinus 60 degrees. Again, FD over sinus 60 degrees equals to BD over sinus theta. But we know that the value of BD is 2 units, and sinus theta is sinus theta. FD, we have already found out the value of FD is A, and A equals to the root of 7 units. And sinus 60 degrees equals to the root of 3 over 2. Okay, so BD equals to 2 units, sinus theta is sinus theta, FD equals to root 7, and sinus 60 degrees is root 3 over 2. Okay, so here we will do the simple arithmetic here. We'll put 2 in the numerator and root of 3 in the denominator of root 7 over 1. We will get that 2 over sinus theta equals to 2 times root 7 over root 3. Okay, we put 2 in the denominator of this number and root of 3 here in the denominator of root 7 over root 1 and 2 in the numerator of root 7 over root 1. In the next step we'll multiply this equality by sinus theta. First of all, we have 2 in the numerator of this side of the equation, and we have 2 in the numerator of the other side of the equation. So 2 can be cancelled. Then we will multiply this equality by sinus theta. We will get that 1 equals to sinus theta of root 7 over root 3. Okay, we got that 1 equals to sinus theta over root 7, sinus theta times root 7 over root 3. We will multiply this equality by root 3, and we will get that root 3 equals to root 7 times sinus theta. So we multiplied this equality by root 3, we got that root 3 equals to root 7 times sinus theta. We will divide this equality by root 7 and we will get the value of sinus theta. Actually, sinus theta equals to root of 3 over root 7. We divided this equality by root 7 and we got that sinus theta equals to root 3 over root 7. Okay, so we know the value of sinus theta, and we will get the value of cosinus theta from the trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. Okay, this is the first trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. In this identity, we subtract from this equation sinus theta squared, and we will get that cosinus theta squared equals to 1 minus sinus theta squared. Okay, we subtracted sinus theta squared from this equality and we got that cosinus theta squared equals to 1 minus sinus theta squared. Now we will take a root out of this equality we'll get the value of cosinus theta. So cosinus theta equals to the root of 1 minus sinus theta squared. Okay, cosinus theta equals to the root of 1 minus sinus theta squared. But we know that the value of sinus theta is root 3 over root 7. The value of sinus theta is root 3 over root 7. So if the value of sinus theta is root 3 over root 7, then the value of sinus theta squared will be equal to 3 over 7. If sinus theta equals to the root of 3 over root 7, then sinus theta squared equals to 3 over 7. So we can substitute sinus theta squared of this equality by 3 over 7, because sinus theta squared equals to 3 over 7. And we get that cosinus theta equals to the root of 1 minus 3 over 7. We substituted sinus theta squared by 3 over 7, and we got that cosinus theta equals to 1 minus 3 over 7. 1 minus 3 over 7 equals to 4 over 7. So actually cosinus theta will be equal to the root of 4 over 7. Okay? So cosinus theta equals to the root of 4 over 7. The root of 4 is 2, so I will write it down. We will get that the value of cosinus theta is 2 over root 7. Okay, cosinus theta equals to 2 over root 7. And we have already found out that the value of sinus theta equals to the root of 3 over root of 7. Okay, we've already found out that the value of sinus theta equals to the root of 3 over root 7. Okay. In the next step, we will create our first equation that states that the sum of the angles in any triangle, and especially in triangle PFD, equals to 180 and 80 degrees. The sum of the angles in any triangle, and especially in triangle BFD, equals to 180 degrees. So in triangle BFD, the small triangle BFD, the sum of its angles equals to 180 degrees. That will be our first equation. What are the angles of triangle BFD? Is 60 degrees plus alpha plus theta, it equals to 180 degrees, and the same is true for triangle DEC. The sum of its angles equals to 180 degrees. So in triangle DEC, the sum of its angles equals to 180 degrees. The angles of triangle DEC is 60 degrees plus gamma plus beta, and it equals to 180 degrees. Okay, so we created two equations. Equation number 1 states that the sum of the angles in triangle BFD equals to 180 degrees, and equation number 2 states that the sum of the angles in triangle DEC also equals to 180 degrees. Now we will add together equation number 1 to equation number 2. Okay, we will add equation number 1 to equation number 2, and we will get that equation number 3, 60 degrees plus 60 degrees is 120 degrees, plus alpha plus theta, plus gamma plus beta, equals to 180 degrees plus 180 degrees equals to 360 degrees. Okay, so we added equation number 1 to equation number 2, and we created equation number 3. In equation number 3 we can subtract 180 degrees from both sides of the equation, and we will get that alpha plus theta plus gamma plus beta equals to 360 degrees minus 120 degrees equals to 240 degrees. So alpha plus theta plus gamma plus beta equals to 240 degrees. Okay, now we'll create the fourth equation that states that the sum of the angles on the upper side of a straight line or line segments equals to 180 degrees. So the sum of the angles in point A on the line segment BC, on the straight line BC, equals to alpha plus 90 degrees plus gamma. That is the sum of the angles in the upper side of BC, of line segment BC, it equals to 180 degrees. So our fourth equation states that the sum of the angles in the upper side of a straight line or line segments equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. Okay, our fourth equation is alpha plus 90 degrees plus gamma equals to 180 degrees. We will subtract 90 degrees from equation number 4, and we will get that alpha plus gamma equals to 90 degrees. Equation number 4 states that alpha plus gamma equals to 90 degrees. Okay, alpha plus gamma equals to 90 degrees, but we have alpha plus gamma in the third equation. So we can substitute alpha plus gamma in the third equation by 90 degrees, because alpha plus gamma equals to 90 degrees. Okay, so we will substitute alpha plus gamma in the third equation by 90 degrees. And we will get that 90 degrees plus theta plus beta equals to 180 degrees. And equals to 240 degrees. We got that 90 degrees plus theta plus beta equals to 240 degrees, because we substituted alpha plus beta by 90 degrees in the third equation. So we got that 90 degrees plus theta plus beta equals to 240 degrees. Now we will subtract 90 degrees from equation number 3. And we will get that theta plus beta equals to 150 degrees. Okay, we got that theta plus beta equals to 150 degrees. Now we subtract theta from this equation, equation number 3, and we will get that beta equals to 150 degrees minus theta. Okay, we know that beta equals to 150 degrees minus theta. Okay, but if beta equals to 150 degrees minus theta, then sinus beta will be equal to sinus 150 degrees minus theta. Okay, very simple. If beta equals to 150 degrees minus theta, then sinus beta equals to sinus 150 degrees minus theta. And we will calculate the value of sinus 150 degrees minus theta according to the second trigonometric identity that states that the value of sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. Okay, we have this second trigonometric identity that states that the value of sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. Here we'll substitute alpha by 150 degrees and we will substitute beta by theta. Okay, so we will get that sinus 150 degrees minus theta equals to sinus 150 degrees times cosinus theta minus sinus theta times cosinus 150 degrees. Okay, we substituted alpha by 150 degrees and beta by theta, and we got this equality. Okay, sinus 150 degrees times cosinus theta minus sinus theta times cosinus 150 degrees. This equals to sinus 150 degrees minus theta, that equals to sinus beta. Okay, what is the value of sinus 150 degrees? The value of sinus 150 degrees is 1 over 2, and we have already calculated the value of cosinus theta. The value of cosinus theta equals to 2 over root 7. Okay, minus sinus theta we have already calculated the value of sinus theta. It equals to the root of 3 over root 7 times cosinus 150 degrees. The value of cosinus 150 degrees is actually minus root 3 over root 2. So in total we got that 1 over 2 times 2 over root 7 minus root 3 over root 7 minus root 3 over 2. That is the value of sinus 150 degrees, that equals to sinus beta. Here we have 2 in the numerator and 2 in the denominator, so we can cancel 2, and minus times minus is plus, and root 3 times root 3 equals to 3. So in total we will get 1 over root 7 plus 3 over 2 times 1 over root 7. Okay? So actually the value of sinus beta equals to 1 over root 7 plus 1 over root 7 times 3 over 2. So the value of sinus beta is 1 over root 7 times 1 over root 7 times 3 over 2. Now we can take 1 over root 7, we can take out 1 over root 7 as common factor in this expression, and we will get that sinus beta equals to 1 over root 7 is a common factor. We took out 1 over root 7 as a common factor of this expression. So in the brackets we will have 1 plus 3 over 2. So sinus beta equals to 1 over root 7 times 1 plus 3 over 2. 1 plus 3 over 2 is actually 2 halves, and 2 halves is actually 5, 2 and half is 2 and half, and 2 and half is actually 5 halves. Okay, so we write it down that the value of sinus beta equals to 1 over root 7 times 5 over 2. Okay, we actually found out the value of sinus beta. It equals to 5 over root 7 times 2. Okay, now we'll focus on triangle DEC, and we will actually implement the law of sines in triangle DEC, in this small triangle, in order to find out the value of B. According to the law of sines in triangle DEC, DE over sinus 60 degrees equals to DC over sinus beta. Again, according to the law of sines in the small triangle DEC, DE over sinus 60 degrees equals to DC over sinus beta. Okay, DE over sinus 60 degrees equals to DC over sinus beta. Okay, the value of DE equals to B. We defined DE as B, so we substitute DE by B, and the value of sinus 60 degrees equals to root 3 over 2. All equals to DC. DC equals to 4 units. It is given us in the question. DC equals to 4 units. And we've already found out the value of sinus beta. The value of sinus beta is actually 5 over 2 times root 7. Okay, so in total, here DE equals to B, and sinus beta equals sinus 60 degrees equals to the root of 3 over 2, and DC equals to 4 units, and sinus beta equals to 5 over 2 times root 7. Okay, we will do here the simple arithmetic. We will put 2 in the numerator and root 3 in the denominator of b over 1, and we will put 2 times root 7 in the numerator, and we will put 5 in the denominator of 4 over 1. Of 4 over 1. Okay, so we'll get that two times b over root 3 equals to 4 times 2 times root 7 over 5. Okay, we did the simple arithmetic here, and we got that 2 times b over root 3 equals to 4 times 2 over root 7, 2 times 4 times root 7 over 5. Here we have 2 in the numerator of this side of the equation, and we have 2 in the numerator of the other side of the equation, so 2 is cancelled, and in the next step we will multiply this equality by root of 3 in order to get the value of b. Okay, so b will be equal to the root of 3 times 4 times root of 7 over 5. So we found out the value of b. B equals to root of 3 times 4 times root 7 times over 5. But we have already found out that the value of a is root 7 units. The value of a is root 7 units. And actually the area of any triangle equals to the base of the triangle times the height to the base over 2. So the area of the green triangle FDE, the area of triangle FDE will be equal to the base of the triangle, that is to say B, times the height to the base, that is A, over 2. Okay, so the area of the green triangle equals to B times A over 2. Okay, so the area of the green triangle EDF of the green triangle EDF equals to A times B over 2. A equals to the root 7 units. B equals to root 7 times root 3 times 4 over 5, and that is A times B. We'll divide A times B by 2. Okay, so the area of triangle, the green triangle EDF equals to root of 7 times root of 7 is 7, and 4 over 2 is 2, where it is times root of 3 over 5. Okay, again, root of 7 times root of 7 is 7, and 4 over 2 is 2, and we have here times root of 3 over 5. Okay, and 7 times 2 is 14. So in total we got that the area of the green triangle EDF equals to 15 times root 3 over 5 square units. Okay, so the area of the green triangle EDF equals to 14 times root 3 over 5 square units, or in terms of numbers, the area of the green triangle EDF equals to 4.85 square units. Okay, so the area of the green triangle EDF equals to 4.85 square units. Again, the area of the green triangle equals to 4.85 square units. Okay, now I will summarize the lecture. Actually, we wanted to find out the area of the green triangle EDF. The data that we have is we have an equilateral triangle ABC, and we know that AF equals to BF. BD equals to 2 units and DC equals to 4 units. And we want to find out the area of the green triangle. Okay? So we know that in any equilateral triangle, the angles of any equilateral triangle equals to 60 degrees. So angle BAC is 60 degrees, angle ABC is 60 degrees, and angle ACB of the equilateral triangle ABC equals to 60 degrees. And we also know that all the sides of any equilateral triangle are equal to each other, so AB equals to BC equals to AC, and it is given us in the question that BD equals to 2 units and DC equals to 4 units. And actually BC equals to BD plus DC. So BC equals to 2 units plus 4 units, or BC equals to 6 units. So we found out that every side of this equilateral triangle ABC equals to 6 units. Okay? So actually AB equals to BC, AB equals to AC equals to BC equals to 6 units. And we defined AF as X. We know that AF equals to BF. We defined AF as X. So if AF is X and AF equals to BF, so BF also will be X. So, but AB equals to AF plus BF. Okay, so actually AB equals to AF, that is X, plus BF, that is also X. So in other words, we can say that AB equals to 2X. Okay, AB equals to 2X, and we know that also AB equals to 6 units. So we can say that 2X equals to 6 units. We divided this equality by 2 and we got that X equals to 3 units. Okay, X equals to 3 units. So AF equals to 3 units and AF equals to 3 units and BF also equals to 3 units. Okay, and in the next step we defined FD as A and DE as B, and in order to find out the value of A, that is FD, we implemented the law of cosines in the small triangle BFD, this small triangle BFD. According to the law of cosines, in any triangle, if this side is A, this side is B, and this side is C, then C square equals to A square plus B square minus 2 times AB cosinus theta. Okay, in any triangle, C square equals to A square plus B square minus 2 times AB cosinus theta. So we implemented the law of cosines in the small triangle BFD, this small triangle. According to the law of cosines, FD square equals to BF square plus BD square minus 2 times BF times BD cosinus 60 degrees. Okay, FD square equals to BF square plus DB square plus BD square minus 2 times FB times BD times cosinus 60 degrees. Okay, and we actually know all the values of all the line segments here. BF equals to 3 units, BD equals to 2 units, sinus 60 degrees is half, 1 over 2, and the only missing variable is A. So we put the data inside this equality, and we got that the value of A equals to root of 7 units, and then we defined angle BFD as theta, we defined angle FDB as alpha, we also defined angle EDC as gamma, and we defined angle DEC as beta. And then we implemented the law of sines in triangle BFD in order to find the value of sinus theta. What is the law of sines? The law of sines states that in any triangle the following relationship exists between the sides of the triangle to the angles of the triangle. That is to say, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. It is true in any triangle. Okay, so we can implement the law of sines in the small triangle FBD. According to the law of sines in the small triangle FBD, BD over sinus theta equals to FD over sinus 60 degrees. Again, BD over sinus theta equals to FD over sinus 60 degrees. Okay, BD over sinus theta equals to FD over sinus 60 degrees. Okay, we know that BD equals to 2, sinus theta is sinus theta. We know that FD equals to root 7 units, and sinus 60 degrees equals to root 3 over 2. Okay, so we put the data inside this equality, and we found that sinus theta equals to the root of 3 over root 7. In the next step, we found the value of cosinus theta by the trigonometric identity, the first trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. Okay, from this trigonometric identity we subtracted sinus theta squared, and we got that cosinus theta squared equals to 1 minus sinus theta squared. Then we took a root out of this equality, and we got that cosinus theta equals to the root of 1 minus sinus theta squared. Okay, we have already found out that the value of sinus theta equals to the root of 3 over root 7. So if sinus theta equals to the root of 3 over root 7, then sinus theta squared will be equal to 3 over 7. Okay, so we can substitute sinus theta squared by 3 over 7, because sinus theta squared equals to 3 over 7. So we substituted sinus theta squared by 3 over 7, and we got that cosinus theta equals to the root of 1 minus 3 over 7. 1 minus 3 over 7 is 4 over 7. Okay, so we got that cosinus theta equals to the root of 4 over 7. The root of 4 is 2, so we got that cosinus theta equals to 2 over root of 7, and we have already found out that sinus theta equals to root of 3 over root 7. Okay, then we actually created 3 equations, so we created 4 equations. The first equation states that the sum of the angles in any triangle, and especially in triangle BFD, equals to 180 degrees. So in triangle BFD, the sum of its angles equals to 180 degrees. That is to say 60 degrees plus alpha plus theta equals to 180 degrees. And the second equation is that the sum of the angles in triangle DEC equals to 180 degrees. That is to say 60 degrees plus gamma plus beta equals to 180 degrees. 60 degrees plus gamma plus beta equals to 180 degrees. Then we added equation number 1 to equation number 2. We got equation number 3 by adding equation number 1 to equation number 2. And this is the third equation, and we created the fourth equation that states that the sum of the angles in the upper side of a straight line or line segment equals to 180 degrees. So at point D, the sum of the angles of line segment BC, the sum of the angles on the upper side of line segment BC equals to 180 degrees. That is to say alpha plus 90 degrees plus gamma equals to 180 degrees. So that is our fourth equation that states that the sum of the angles in the upper side of a line or line segments equals to 180 degrees. So alpha plus 90 degrees plus gamma equals to 180 degrees. So from equation number 4, we derive this equality that alpha plus gamma equals to 90 degrees. But in the third equation, we have alpha plus gamma. So we can substitute alpha plus gamma by 90 degrees in the third equation because alpha plus gamma equals to 90 degrees. So we substituted alpha plus gamma in the third equation by 90 degrees. And we got that theta plus beta equals to 150 degrees, or beta equals to 150 degrees minus theta. Okay, so if beta equals to 150 degrees minus theta, then sinus beta equals to sinus 150 degrees minus theta. So in order to find out the value of sinus 150 degrees minus theta, we used the second trigonometric identity that states that the value of sinus alpha minus beta is sinus alpha cosinus beta minus sinus beta cosinus alpha. So we substituted alpha by 180 degrees and theta and beta by theta. Okay, so we actually found out the value of sinus beta because sinus beta equals to sinus 150 degrees minus theta. Okay, so by this trigonometric identity, we found the value of sinus 180 degrees minus theta, that is actually equals to sinus beta. And we found out that the value of sinus beta is 5 over root 7 times 2. Okay? So after we found the value of sinus beta, we actually can find the value of B by implementing the law of sines in triangle DEC, the small triangle DEC. If we implement the law of sines in the small triangle DEC, it is actually DE over sinus 60 degrees equals to DC over sinus beta. Again, DE over sinus 60 degrees equals to DC over sinus beta. Okay? So we implemented the law of sines in the small triangle DEC. According to the law of sines, DE over sinus 60 degrees equals to DC over sinus beta. And we know that D is B is the missing variable. Sinus theta equals to the root of 3 over 2. DC equals to 4 units. And sinus beta, we have already found out the value of sinus beta. It is actually 5 over root of 7 times 2. Okay, so the only missing variable here is B. Okay, so, and we found out that the value of B is actually root of 7 times 4, root of 3 times 4 times root of 7 over 5 units. Okay, and we have already found out the value of A. The value of A is root of 7 units. So we actually know the value of A and the value of B. And the area of any triangle is the base of the triangle times the height to the base over 2. So the area of the green triangle is the base of the triangle, that is B, times the height to the base, that is A, over 2. We should remember that the height must create 90 degrees with the base. And here you can see that the height A creates 90 degrees with the base B. Okay? So A times B over 2 is the area of the green triangle. Okay? So the area of the green triangle is A times B over 2. We found the value of, we have already found out the value of B, and we know we have already found out the value of A. So the only thing that we need to do is to put the value of A and B in this formula. Okay? And we found out that the area of the green triangle EDF equals to 14 times root 3 over 5 square units, or in terms of numbers, the area of the green triangle EDF equals to 4.85 units. Again, the area of the green triangle EDF equals to 4.85 units. Okay, thank you very much.